why A can be easily removed from max phases to get MXene? Because we know we get MXene from max phases. This is max phases formula. When we remove this A, we get MXene. This is a MXene formula, right? The question arises that why not M? Why not X? When A can be removed during etching process or some other process, why not M? Why not X? Let's answer this question. Look into this structure of max phases. This is basically M atoms. This green is also M atom. So this is basically M2. And these M atom basically bonded with X is a covalent bond. You can see here. It's a strong bond. And this is A layer, A atom layers. And again we have that similar M2X. And again we have A layer, again we have M2X. So once we remove these A layers, during etching process, there are many methods, but etching process, so then we get stack layers of M2X. This means if it is titania carbon, we call Ti2C or Ti2S silicon, Si. So this is how we get MXene. So let's answer this. We know that max phases that can be used to make MXene, it must have a strong bond between M and X. You can also see here that these two, the layer of these two atoms are basically attached through covalent or ionic bond. But this is basically, this is also, you can see this A is also like aluminum. So this is M is also a transition metal. So there is a basically a metallic bond between these M and this A here. This Ma bond is basically metallic bond, and metallic bond is a weak bond as compared to ionic bond or covalent bond, while the MX are basically bounded with each other through covalent bond or ionic bond, right? And this Ma bond are basically, look here, look there, these are basically metallic bonds, so these are weakers. So these are weakers, so when we drop basically this makes powder in a etching agent like HF or some other etching agents, so this bond is weak, so it shows no resistance, so it will automatically break. So you see during the etching process, Ma bonds are broken and A layer are removed. When these A layer removed, we get basically MXene, right? Stacking MXene. According to this standard criteria, this is basically max phase here. So this A can be easily removed to get Ti3C2 MXene, because the bond between Ti and A is weaker. This is basically metallic, where the bond between Ti and carbon is stronger because it is a covalent bond, right? This is how we get MXene. And if you compare now these two, it's a very important slide. This is basically max phase and this is also max phase. This is nitride base, this is carbon base. So in the later, this one cannot make MXene. Why? Because the bond between the nitrogen and titania is weaker than the bond between these two. So in that case, we remove N. So when we remove N, so we don't get MXene. But here, this bond is basically stronger than this one. So this is why we get MXene from this, but we cannot get MXene from this. And this is somehow a nitride based MXene are very rare. In most of the case, it's a carbide.